So, dear students, in this video, we'll be seeing about associative memory networks. So, associative memory, it is used to store the patterns as memories. So, this is also called as content addressable memories, where we are going to take a pattern as input and we are going to search and find out a pattern which is very closely related to this pattern. In conventionally, you will be giving an address and you will be finding out the data what is present in a particular address, but here we are searching with respect to a content, so we call this type of memory as content addressable memory. And there are two types of associative memory. One is the auto associative memory, the other is a hetero associative memory. So both of these networks are single layer networks, where you have one input layer and other output layer, and it is going to find out output vector which is corresponding or correlated with the input vector. So that is the purpose of this particular network. You're giving an input vector and you're going to find out an output vector which is similar to or which is matching the input vector. So this is a structure of content addressable memory. So we are having an input data set which is in terms of vector, and we are going to give it to the memory and we are going to get an output vector. But it says whether it's matches or no match, because even in hetero associative memory we are going to find out a pattern which is not similar to or which is different from the input data. So it will be saying outputting a data which is matching or not matching. So here they are talking about a Hamming distance. So in nutshell, what I would like to say, Hamming distance is if you give two vectors, it will find out all the positions in which they don't match. So Hamming distance is nothing but the number of uh, values in which the two vectors does not match. So that is the Hamming distance. And you also know Euclidean distance, which is root of x minus y the whole square, or root of x1 minus y1 the whole square plus x2 minus y2 the whole square, and so on. Okay, plus etc xn minus yn the whole square. So this is how we find out the distance between 2 points in a Euclidean distance. So the 2 points here we will consider as two vectors, where x is the input vector and y is the output vector. With the help of this distance matrix, we try to find out whether the two vectors are similar or different. So the first topic is training algorithms for pattern association. There are two rules. One is the Hebb rule, the other is the outer product rule. So Hebb rule we saw in the last class itself, in the class physical class what we had. So Hebb rule is to find out, both these rules are going to find out the weight of a network, the associate network. So any neural network, the first step is to design the weight or define the weights. Once you define the weights, the neural network is constructed, and here on the network can be used for whatever the purpose it was intended, maybe speech processing or image processing and so on. So here the Hebb's rule is used to find out the weights. Similarly, the outer product rule is also used to find out the weights of the associate memory neural net. And here we are going to first, the step is to initialize all the weights to 0. So where you are having the input vector indexed in the range of 1 to n and the output vector indexed in the range of 1 to m. So here you are going to repeat the steps 2 to 4 for each and every input output vector pairs, that is tuples. For every tuple you are going to repeat the step. So the first input layer, like what we have studied in the ANN, in the first input layer, when you are feeding the training input, the output of the input layer will be the same input. So it is xi will be equal to si, where si is the source vector and ti stands for the uh, target vector. Okay, s stands for the source and t stands for the target vector. Nothing but s is the input and t is the output, the matching output. So xi is equal to si, and the output layer, the input will be, already we are having the data, right? So the target is there, so the yi will be nothing but, or j, we can index it as j. So yj will be equal to tj, that is the target. Okay, And weight updation, the rule for weight updation is the new weight will be equal to the old weight plus the product of the source value and the target value. That is nothing but the value at the input unit and the value at the output unit. So you multiply these two and you will be updating the weight. So here see the flow chart. That shows the initializing of weights to 0 for each and every source and target pair. What you're going to do is you're going to present the input signals, and your input will be equal to the source value, and the output will be equal to the target value, and the weight is adjusted using the formula. New weight will be equal to old weight plus xi into yj, and it will stop. So this is the Heb's rule. So in this way we will be repeating this step for every training tuple, and finally you will be having the adjusted weight. So this vectors can be either a binary vector of form 0 to values between 0 to 1, or it can be binary in the sense 0 or 1, or it can be even bipolar vectors which is having the value of +1 to -1. So this is the outer product rule. The outer product rule is an alternate method for finding the weights of an associate net. So here they are just changing the representation. The input S is given in the form of S1 etc. up to Si etc. up to Sn, and output T is given in the form of T1, Tj etc. up to Tm. So now you're going to take the outer product of these two vectors. It is the product of the matrices actually. So to multiply it, what you're going to do is to make the vector um, uh, uh, compatible to multiply, we are making the transpose of S. So S transpose, the input vector is made a transpose and the output vector is T. And now what you do is, so this is a format. So in order to make the outer product between S and T, we are making the transpose of T and multiplying by T, because we are having an index of N and we are having an index of M. So to multiply them, we are making a transpose of this vector, and now this vector will become N cross 1 because you are having N rows, and this vector will become 1 cross M. So they can be multiplied. Okay. And now after matching the order of the two matrices, now the resulting weight vector will be a vector of the form order n cross m. The output vector will be in the order of n cross m. So every row here will be multiplied with this row here. So it is S1 into T1 etc. up to S1 into Tj etc. up to S1 into Tm. Similarly S2. Similarly this Si into T1, Si into Tj etc. up to Si into Tm. And the last row Sn into T1 etc. up to Sn into Tj etc. up to Sn into Sm. Okay, so the weight is find out, and this is how the weight is determined with the help of product rule of two vectors. And when you're making a set of values, that is set of associations, now you're not having a single pattern, you are having a set of patterns in your hand, and you want to find out a set of patterns which are similar to this pattern. Okay, the output is also a set and input is also a set. Now the rule can be modified like this. That is, we are having p points or p sets, p values inside the set, where p ranges from 1 to capital P. So we are having S of p, we are having p number of points in patterns inside the source vector. Similarly, we are having p number of values in the target vector. If that is the case, now the vector can be represented like this, and the weight calculation will be modified a little bit. See here, the weight of Wij is equal to, we are having several points, right? So it is sigma p equal to 1 to capital P, yes, I transpose of p into Tj p. So, okay, so we are multiplying it and we are making a summation when you are having a set of patterns and you want to find out a set of patterns which are matching. So we take the cumulative weight, okay, sum of the weights. So this can also be written like this, that is W equal to sigma p equal to 1 to capital P S transpose of p into T of p. Simple. We want the collective weight of all the patterns what is there in the given input set. So like this, we can use either the Heb's rule or the outer product rule to find out the weight of the associative network. So first type is auto associative memory network. So this is to find out, given an input vector, you will be able to find out a target which is closely matching. So that is the auto associative network. So here first step is to determine the weights and to finalize the network. So the architecture of this neural network is given in this diagram. So this architecture looks like this. So we are having an input vector whose index is in the range of 1 to n. You are having n values. It is an n vector. And you're having output or target ranged in the y1 etc up to yj etc up to ym. So the size is m. So every node is connected with every other node here. So every unit is connected with every other unit here. And see the weight. The weight is with respect to the nodes what is connected. So if you're connecting node x1 with y1, then the weight is w11 and so on. So this is a target what is coming out, y1 etc up to yj, and here we will be having ym as the output. So now the training process and the testing process are separated. So this is the training step. So here you are having the initialization of weights. Again, you are going to initialize to 0, and you are having two indexes. One is for the input vector ranging from 1 to n, and the other is for the output vector ranging from 1 to m. No, actually, in the case of auto associative, the very important property is that is the two vectors are same. Okay, so if you could see here, the first point itself, the training input and the target output vectors are same. So they're not n and m, they are both n and n. So the indexes are same. Okay, we are going to find out a similar vector. Okay, the same length vector. Okay, so first is that is the main thing. So here also it is xn, and if you see here it's also yn, it's not m. Okay, so that's a very important difference between auto associative network and hetero auto associative network. So if it is there is n input units, then there will be n output units. Okay, so that's a very important difference what you should observe. So I equal to 1 to n, and the output also ranges from 1 to n. And for each vector, what you're going to do is you're going to activate the input units using the same method. That is, the source will be equal to, or the xi will be equal to si, and the output units will be yi, which will be equal to again um, si. That is the target actually. Okay. So here we are taking it as yes, because we consider that both are same, the input and the output are same. Now say for example, where we are using this particular method is to find out a missing value or a noisy image is there, we try to find out a perfect image. Say for example, in text based purposes, suppose I am typing a word brai, okay, but or say I am typing barn, in. Okay, there is a spelling mistake in the word, but the associative auto associative network can be used to correct this spelling. So in word and all, if you type some word, it corrects, auto correction is there, no? So to make this auto correction, auto filling and all, these type of networks are used because they learn, if you give something wrongly, it will produce an output which is a correct one, correct form of that. Okay, if you give an imperfect image with lot of pixel losses, with lot of misclarity, it will construct a good image, but the source and the output will be the same actually. Okay, now the weight is adjusted using the same formula. Weight new will be equal to weight old plus the product of the input and the output, x and y, xi and yi. Okay, and this will continue. So this is a flowchart of training, and the same is represented in algorithm format. So the important difference is the same number of, see if you see this training algorithm is same from the algorithm what we saw in the Hebb's rule, but the only difference is the same numbers of output units as that of input units. Okay, so we are going to initialize all the weights, I equal to 1 to n and j equal to 1 to n, and then for each vector you are going to, that has to be stored, we are going to repeat this step 2 to 4. So only we consider the source vector, activate each of the input unit. So we are going to activate xi will be equal to si. Similarly, each output unit yj will be equal to sj, and while you are adjusting the weight, the new weight will be equal to old weight plus xi into yj. The weight can also be determined using the formula when it is a set of patterns, W equal to sigma P equal to 1 to capital P, S transpose of P into S transpose of P or T transpose of P. They have corrected it, but here in the case of auto associative network, they have considered, since both are of the same unit, they are considering like that. Even you can assume the output as T. Okay, testing algorithm, the auto associative neural net can be used to determine whether the given input vector is a known vector or an unknown vector. Sometimes you give a mistake, it doesn't correct it because there is no such word known. At that case, this network will output that there is no suggestion and all. You would have seen, no, there is no suggestion. Suppose similar kind of words it has already seen or it is there in the stored memory, it will auto correct it or it will suggest, give you some suggest suggestion. Okay, so the testing procedure, again we are going to use Heb's rule or the product rule to find out the weights, and you are initializing the weights and you are creating the network first, and then you are passing this for each testing input. You are going to repeat this step. So first step is you have to find out, இப்போ வந்து டெஸ்டிங் பண்றோம். ஓகே, அவுட்புட்டை டிட்டர்மைன் பண்ண போறோம். ஓகே, calculate the net input to each output unit j equal to 1 to n. So output unitல வந்து போற input என்னன்னு பார்க்க போறோம். ஓகே, so first layer input layer இருக்க போது. ஓகே, so this is the input layer, this is the output layer. so inputல எப்பவுமே வந்து நம்ம இங்க என்ன கொடுக்குறோமோ அது இங்க வந்துரும். so இங்க என்ன இருக்க போகுதுன்னு பார்க்க போறோம். what will be the input, what it is going to y. so that will be the natural multiplication of w and x, right? அதான் சொல்லி தந்தேன் இல்லையா நேத்து. okay, so that will be the multiplication of, see, the input at the output unit y, I and j, that is the link connecting I and j. The two nodes I and j will be sigma I equal to 1 to n, the value of x into w. Okay, xi into wj, that is all the nodes what is coming inside. இங்க நிறைய node வரும் இல்லையா? so see here, there is 1 node, 2 node, 3 node, இது எல்லாத்தோட summation. so we have to multiply xi with y w, and similarly xn with w, and then xn with w, and sum of all these things, that will be the y value. Okay, and the naturally what I told you, so when the input will be nothing but the multiplication of the input here and the weight and the sum of all these things, but the output here will be the activation function will be playing a major role. so whatever is coming as input, you have to apply a activation function, and that will be output. so the activation function can be sigmoid function, logistic function, and so on. okay, ReLU or whatever it is. so here we are going to apply an activation function. so what is the activation function? so we are going to calculate the output by applying the activation function over the input. so it is y is equal to f of this whatever is the input what is coming inside, that is y I n j, which is equal to, if the y value what is coming in is greater than 0, it will output +1, and if it is less than or equal to 0, it will output -1. okay, so that is the output what you will be getting. so based on this threshold value, the correct classification will be done. Either it is a match or not match, or whether it is a known vector or it is not a known vector. okay, so this kind of network can be used in speech processing, image processing, and pattern classification. so the next is the heteroassociative memory network. so the heteroassociative memory network, here the training vector and the target vector are different. They may have different input output units. so here we specifically mention them as the input vector is in the range of 1 to n, and the output vector is in the range of 1 to m. so if you see here, each source is equal to n components, and each output vector t has m components, and we are going to determine the weight with respect to Heb's rule or outer product rule. And here the architecture of this particular network is shown here. so you could see the architecture. see here, the only difference is the two vectors are different in terms of the order and in terms of the values. so we are going to give an input and we are going to get a different pattern which is not similar to this, entirely different thing. so that is also needed. In some cases we want to generate an entirely new picture which not similar to this. So here we are having x1 etc. up to xn and y1 etc. up to ym, and all the other things are going to remain the same. Okay, so here uh, we are going to find out the input and output layer units are not correlated with each other. They are not similar. That's the reason why we call this network as heteroassociative network. Okay. So here, while you are training, that is going to be the same, but while you are testing it, it is going to initialize the weights and then perform um, the step repeatedly. The steps is going to repeat. Activation in the input layer equals the current input. So this is always known. So whatever you give as input, that is SI, that will be the XI value. So XI will be equal to SI. So this already I have explained in ANN, as well as we have seen in auto associated networks. That's the same. Your X will be equal to S, whatever you are giving as input. So what you are getting here, that is your X will be equal to S, what you are giving inside here. And the input to the output unit, that is here, what is the input here will be nothing but the multiplication of W into X. Okay, the multiplication of W into X. So it is Yinj is equal to sigma I equal to 1 to n Xi Wij Wg Ij, that is index between X and Y. So where J stands between 1 to m. Okay, so there are n units. For each and n unit you are going to multiply the input with the weight. And now the activation function, that is the input here is determined, the output here will be determined by the activation function what you are applying here. So the activation function is some f of y. So here the activation function is little different. So if the value what is coming inside is positive, it will output 1, and if the value coming inside is 0, it will output 0, and if it is less than 0, it will be outputting -1. So this kind of network we will call it as bipolar, because it is giving minus value 0 as well as 1. Okay. Mm. And even the output activation function can be like this, that is whenever it is positive or equal to 0, it will output 1, and if it is less than 0, the output will be 0. There are different kinds of activation functions which will be generating different types of values based on the input value. So we can choose an appropriate activation function meaningfully for what is the task we are going to do. The last one is bidirectional associative memory. Bidirectional associative memory is invented by Costco in the year 1988. So it is BAM is, as a name suggests, bidirectional. It is a forward as well as a backward associative search. That is, it feeds the input forward as well as it takes the input backward also to learn it effectively. So here there are two types. One is discrete and the other is continuous bidirectional associative memory. Okay, so here again we will be seeing the network first. Okay, so this is the network. So here if you could see the network here is bidirectional. So the weight here, that is arrow here, is going forward as well as it is coming in the reverse direction. So every weight, otherwise the network is going to be same as heteroassociative. We are having n number of components in the input vector x, and you are having m number of components in the output vector y, and W is the vector which is going in the forward direction, and W power T is the vector which is coming in the reverse direction. The same W value, but the transpose of that is, we are saying that the transpose is coming in the reverse direction. That's it. Okay. So here the weight calculation, if it is a binary input vector, the weight is calculated using the formula. So for the set of points, it is calculated, that is sum of P is equal to 1 to capital P 2 into source vector minus 1 into 2 into target vector minus 1. So this is how the weight is determined. But if it is a bipolar vector, in that case the weight is calculated using the formula sigma p is equal to 1 to capital P Si of P into Tj of P. Okay, so there are two difference, whether the vector is binary or whether the vector is bipolar vector. Okay. So these are some of the activation functions for the Y layer and for the X layer. So that is what will happen in the Y value and X value. So here X is also considered because the network is going forward as well as the network is coming backward. So you should understand that. So because of that, we are going to have two different set of activation functions. In the case of binary, what you're going to do is if the value is positive, the what is output will be 1, and if it is equal to 0, it will be output the exact y value itself. Okay va? ymj yinj input வரக்கூடியது 0வா இருந்தா அதுதான் வந்து அதோட அவுட்புட்டாகவும் இருக்கும். And then if it is less than 0, it will output 0. And for bipolar, it will be taking the 1 value and y value and minus 1 value. Okay, that is பைபோலாரில் மட்டும் மைனஸும் இருக்கும். பைனரியில் வந்து மேக்ஸிமம் பாசிபிள் வேல்யூ வந்து 0 or 1 இருக்கும் எப்போவுமே. தட் இஸ் வாட் இஸ் பைனரி. பட் பைபோலார் சொல்கிறப்ப -1 இஸ் ஆல்சோ கன்சிடர் as a value. -1 to +1. It will be considered as a range of values for bipolar vectors. Okay. And then just it is a change in the denotion. That is reverse directionல வரும்போதும் forward directionல வரும்போதும் நம்ம அதை மாற்றுறோம். பட் it is the threshold. Theta is nothing but a threshold. இது வந்து 0. இது வந்து தீட்டான்னு நம்ம சொல்லும்போது it is a threshold value. நம்ம either வந்து 0ஓட கம்பேர் பண்ணி அவுட்புட்டை ப்ரிப்பேர் பண்ணலாம், or else you can compare with any threshold and you can generate a output. So இங்கே வந்து நம்ம predefined threshold. It may be noted that if a threshold value is equal to that of the input calculated, then the process இது வந்து the theta வந்து என்னன்னா threshold. ஓகேவா? Similarly, activation function X layerல reverse directionல வரும்போது X layerல வரும்போது activation function என்ன ஆகுதுன்னு பார்த்தோம்னா பைனரியா இருக்கும்போது it will be 1 and this will be 0 actually, not -1. And similarly bipolar இருக்கும்போது it will be 1 and -1 வரைக்கும் வரும். And similarly either வந்து நம்ம 0 வச்சு செக் பண்ணலாம் அல்லது threshold வச்சு செக் பண்ணிக்கலாம். And testing algorithm. So we are going to initialize the vectors. And then we are going to repeat the steps starting from 2 to 6. Okay. So first you are going to present the input pattern to the X layer and it will reach the Y value. And similarly ஒரு step முடிஞ்சதுக்கு அப்புறம் திரும்ப now இப்போ first layerல இருந்து it will be coming backward. Okay. So here Y எப்படி modify ஆகுதுன்னு பார்க்க போறோம். Y is equal to xi into wij. That is always y will be equal to the product of x into weight vector, and if there are n nodes, we'll be taking the sum of all these n nodes, and then we'll be applying the activation function, and this is f of ymj. நம்ம அந்த activation function வந்து இங்க பார்க்குறோம். either threshold செட் பண்ணி நம்ம அவுட்புட் எடுக்கலாம் அல்லது 0க்கு கம்பேர் பண்ணி அவுட்புட் எடுத்துக்கலாம். எடுத்துட்டு that value y will be given to the x layer. திரும்ப பின்னாடி வரணும் இல்லையா, பிகாஸ் இட்ஸ் அ ஃபார்வர்ட் பேக்வர்ட் நெட்வொர்க். அண்ட் இப்போ எக்ஸுக்கு வரும்போது அகெயின் வி ஹாவ் டு கால்குலேட் த இன்புட். அகெயின் வி ஹாவ் டு எக்ஸுக்கு வரப்போ அகெயின் ஒரு வெயிட் வருது அண்ட் சிமிலர்லி ஒரு ஒய் வருது இல்லையா. ஸோ திஸ் ஒய் வேல்யூ இஸ் கம்மிங் வித் த வெயிட். ஸோ த வேல்யூ அட் எக்ஸ் வில் பி ஈக்குவல் டு சிக்மா ஐ ஜே ஈக்குவல் டு 1 to m, பிகாஸ் வரப்போ m யூனிட்ஸ்லேருந்து வரும். ஸோ த இண்டெக்ஸ் இஸ் ரேஞ்சிங் ஃப்ரம் j is equal to 1 to m yj into wij, and this will be your x value. And again here we have to apply the activation function, and when you apply the activation function f over it, you will be getting an xi value. Okay, திரும்ப again iteration converge ஆகுற வரைக்கும் இது என்ன ஆகும் அப்படின்னா this input will be given to again the y layer. Okay, so till convergence is reached. A convergence can be a threshold, a convergence can be a better accuracy or a minimum error. So this process will continue, keeping on continuing. Okay, so the same thing for the continuous bidirectional associative memory, but it is in the range of 0 to 1. When I say continuous value, it is not discrete values like 0, 1, -1 அப்படி இல்லை. It will be taking all the values in the range of 0 to 1. So that is what is continuous value. நமக்கு நார்மலாக தெரியும் இல்லையா, numerical value can be discrete or continuous. நம்ம ஒரு இன்டிஜர்னு சொல்லும்போது they are discrete. But when you say it is a decimal value, it is a continuous value. Okay, so நம்ம activation function இங்க யூஸ் பண்றது வந்து logistic sigmoid activations function யூஸ் பண்ண போறோம். And here again the weight is calculated. If it is a binary weight, this is calculated with the help of this formula. That is the same formula what we have already seen. And the activation function here is like this. It is looking like this. So if it is a binary logistic function, the activation function is equal to 1 by 1 plus e power minus y some indexing, okay, mj, and the activation function bipolar means it is 2 by 1 plus e power minus ij, which is minus, so which can be written like this. In the denominator எடுத்து திரும்ப LCM எடுத்தோம்னா denominator common ஆயிரும். ஸோ இதை மேலே கொண்டு போய் நம்ம subtract பண்ணோம்னா you will be getting a simplified vector like this. So the activation function for the binary logistic function is this, and the bipolar logistic function is this. Okay. So the net input is calculated with a BIOS also, like நம்மளோட conventional artificial neural network மாதிரி it BIOS is included here. Okay. And the activation நம்ம ஒரு output unitலையும் அதோட input calculate பண்ணுவது it is sum of all the xi into wij, and you have introduced a BIOS also. Only these variations except for discrete and continuous difference என்னன்னா continuously the range of value is 0 to 1, so for which to accommodate that we are going to include a logistic activation function for a binary vector or for a bipolar network. The input can be either a binary vector or it can be a bipolar network. So bipolar ன்றப்ப மைனஸும் வருது, நெகட்டிவ் ஆக்சிஸையும் நம்ம இன்க்ளூட் பண்ணும்போது we say it is a bipolar network. Okay, so with this I complete this.